right, good morning. We're going to go ahead and get started on 2.3e, finding the slope of a line from context. So these little stories should actually look very familiar, that we've used them before when we did all of our part 1, when we were finding proportional constants and finding unit rates. So in this particular problem, it says gourmet jelly beans cost $9 for 2 pounds. Well, right away I'm going to look and I see a $9. So I can go ahead and I can fill in that missing value, and I can go ahead and put that right there. But just like we did in all of part 1, I want to set up that proportional constant so then I can come up with my unit rate, so I can go back and I can fill in the rest of my table. So I'm going to set my dollar over my pounds, so I can figure out how much it is per pound. So in our example, they gave us $9 for 2 pounds. So if I wanted to go and figure out what that unit rate would be, I would do 9 divided by 2. So in your calculator, go ahead and do 9 divided by 2. All right, and you'll get 4.5. So now I can start to fill in my table. So now this table is just like our tables that we use, but due to space, I made the table going across rather than up and down. So we know that my pounds is my X, and my total cost is my Y. So if I buy 0 pounds of candy, my total cost is going to be 0. If I buy 1 pound of that jelly bean, my total cost is going to be 4.50. So now this is where you can start to use your calculator if you need it, and you can start to go ahead and figure out and fill in the rest of the table. That if we fill in 3 pounds of candy, it's going to be $13.50. If I buy 4 pounds of jelly beans, it's going to be $18. Well, now this one's tricky. This one actually gave me the cost, but I need to find out exactly how many pounds of jelly beans I purchased. So if we think about what we did for all of these other ones, we took our data and we multiplied it by 4.5. So if I'm trying to go backwards, the opposite of multiplying will be dividing. So in my calculator, I will do 27 divided by 4.5. And when I do that, I end up with 6. So that means 6 pounds of candy would actually cost me $27. All right, so 8 pounds of candy cost me $36. Have to reverse it again. My $45, I need to figure out how many pounds of jelly beans I purchased. So we do 45 divided by 4.5, and we get the answer of 10 pounds. And last but not least, we do 20 pounds times my $4.50, and that ends up with $90. So now what we're going to do is we have to go down to part B, and it says that we have to graph our relationship. Well, just like we did before in our last unit, we're going to use those answers that they gave us in the table to go ahead and label our graph. So the very first thing we're going to do is we're going to graph my x-axis. So my x-axis is going to be labeled based on my table, pounds. And I see that my table is going from 0 to 20. Well, I have 10 lines. That gets me a decent amount of points, so I'm going to make sure that I number them just by 1. Do not forget to make sure that you put in this scale and that your scale is consistent from the origin all the way to the end. So now I have my y-axis. So I'm going to turn my graph sideways, and according to my table, my y-axis is total cost. So here I have about 20 lines. And if I look and I see where my total cost is going, I can see, well, $20 is going to be right about here. Well, that still gives me a good 5 points. I'm not sure I really want to try to squeeze in points all the way to get to the end of $90 if I bought 20 pounds of jelly beans. So instead what I'm going to do is I'm going to go ahead and keep that scale consistent, and I'm going to count by ones. All right, so I've got my graph set up. So now that my graph is completely set up, now I get to go plot my points, just like what we did in that last unit. So my very first, based on my table, is 0, 0. My next one was at 1 pound, 1 pound of jelly beans cost me $4.50. Well, I come up here to my 4. I need to be somewhere between 4 and 5 because it's $4.50, and I put a dot there. 2 pounds was $9. 3 pounds was $13.50, so between the 13 and 14. And then 4 pounds was $18. Again, we weren't able to graph all of our points in our table, but we at least have a decent number of points. Remember, I always require 3 to 4 points so that we can go ahead and graph our line. So I'm going to connect all of my points, making sure that my graph is actually drawn going past my actual coordinate plane with an arrow on the end. So now we're going to move over to C. So C is asking me for the slope of the line. And this is where sometimes it can get a little bit tricky, because if you remember what I said before, slope must be a fraction or a whole number. It has to be a fraction or a whole number. We are not going to have decimal slopes. It has to be a fraction or a whole number. Because before, what we would do is we learned that our rate of change is the same as our slope. So we would write down that as being 4.5. The problem is that is a decimal. So we have to be able to find a way to be able to come up with our slope. So the first thing I tend to look at is I go and I look at what was that original proportional constant that I came up with just from my context. So if I go up here, I remember I did dollars over pounds, and I had that 9 over that 2. That's how I ended up with that unit rate. So now I can focus on the fact that my slope is the same as saying 9 over 2. So of course I'm going to look and always see if there's a way for me to simplify it. Nothing's going to go into 9 over 2. This is a fraction or a whole number, so I know I have just found my slope. But now part D is asking us to say, what does that slope mean? Okay, we did a lot of that. If we looked back up at our unit rate, we would say it's $4.50 per pound. But now I want it explaining the slope. So it works pretty much the same way. We know that this 9 represented dollars, and we know that the 2 represented pounds. So when I go to answer that question, I get to say that this slope means that it's $9 for 2 pounds of jelly beans. $9 for 2 pounds of jelly beans. So now we get to write an equation. And if you remember from writing an equation when we did it using our unit rates, it was always y equals that rate of change times x plus or minus your initial value. Well, now that we're dealing with slope and we've determined that rate of change is the same as slope, we can now do that same equation of y equals, well, my rate of change is the same as my slope. My slope is up here, which is 9 over 2, x plus or minus my initial value. Well, my initial value was 0, so I don't even have to write plus 0 because now I'm done. So F is saying, why is this data graphed only in the first quadrant? Why, when I made this graph, did my arrow go up saying it went on forever, but I didn't go down? Well, is it possible to buy a negative amount of pounds of jelly beans? No, of course not. It doesn't make any sense. So we can't have negative pounds. So no negative pounds of jelly beans are bought. All right, so let's flip over to problem number 2. All right, so problem number 2 says, Kaylin takes the same amount of time to solve each of the equations on her math homework. She can solve 10 equations in 8 minutes. So A says to complete the table, but as we've determined, it's so much easier to come up with that unit rate in order to fill in my table. So I'm going to figure out what my unit rate is. So we can see that here in my table, I have minutes, which is my x, and equation solved, which is my y. So when I go to try to figure out my unit rate, I know that my equations has to be on the top because it's y over x, with my minutes on the bottom. So based on my context, it says that she solved 10 equations in 8 minutes. So in order to find my unit rate, I'm going to type in my calculator 10 divided by 8. And when I do that, I get the answer of 1.25. So in 0 minutes, does Kaylin solve any equations? Of course not. So now in 2 minutes, I need to then multiply 2 times 1.25 to find out how many equations she solves in 2 minutes. 2.5. 2.5 equations. So now you can see they kind of flip-flopped this again on us, and they gave us this 5, and they said they want to know how many minutes it took her to solve 5 equations. So we found that if we are going to be working backwards, we'll need to divide. So in my calculator, I'll have to type 5 divided by 1.25. And when I do that, I get the answer of 4. 8 times 1.25 is going to give me 10. I'm working my way backwards again. 15 is going, divided by 1.25, is going to give me 12. Not 100% sure why I have this empty box here, so don't worry about it. 20 minutes, she can solve 20 times 1.25. She can solve 25 equations. And now I need to figure out how many minutes it takes her to solve 30 equations. So when I work my way backwards, 30 divided by 1.25 gives me 24. So now part B says it's time to graph them. So again, I'm going to use my table to come up with my X and Y labels, making sure that before I graph any points, I make sure I label them and make sure that my scales are accurate. So according to my table, my X is going to be minutes. And if I look, yeah, it's going from 0 all the way up to 24. But if I count by ones, I can get up to 10, and I can get at least those 3 to 4 points. So I'm going to go ahead and count by ones. So then looking at that, knowing that I'm only going to get up to that 10 minutes, if I look here, that means I'm really only trying to get up to 10 equations solved, so I could have enough points graphed. So again, I can count by ones. If you wanted to skip line, you could. I'm just going to count by 1 just to keep it safe. And my equation solved is going to be my label. So I make sure to turn my graph sideways, label my y-axis as equation solved, and go ahead and do my scale for my y-axis. And like I said, I'm just going to count by 1. It's just easier. Now it's time to graph my point. So I have a point at 0, 0. In 2 minutes, it's 2.5 equations. So it's going to be right between my 2 and my 3. At 4 minutes, notice it jumped. I didn't have anything on my table for 3 minutes. But at 4 minutes, it jumped up to 5 equations. And then I went all the way up to 8 minutes, which got me up to 10 equations. So I'm going to go ahead and grab my straight edge, my ruler, and make sure that I connect all of my points and draw my arrow at the end, saying that it does go on forever and ever. So part C says, what is the slope of the line? So remember, slope has to be a fraction or a whole number. It cannot be that decimal, that 1.25. We know that's our rate of change. She can complete 1 1/4 equations in 1 minute. However, I need to come up with my slope, and my slope has to be my fraction, or it has to be that whole number. So I look back up at what did I do when I did that proportional constant. So my slope, I'm going to use that, which is my 10 over my 8. Now, of course, I always want to look to see if it can be reduced. So I ask myself if anything can go into both 10 and 8, and I see that 2 can. So 10 divided by 2 is 5, 8 divided by 2 is 4. Now my slope has been simplified, and I have that 1.25, that unit rate, in terms of a fraction. So of course it wants to know, what does that slope mean in that context? Well, according to my context, it means my top was my equations and my bottom was my minutes. So what that means is that Kaylin can solve five equations in 4 minutes. This is why when I make my proportional constants, I love to be able to have them labeled, because then I know exactly what that top number is representing, which is my y, in terms of my bottom number, which is my x. So Kaylin can solve 5 equations in 4 minutes. So now it wants us to write an equation and what that would look like. So we remember that in order to solve an equation, we had learned that it was y equals that rate of change times x plus or minus my initial value. And we've now learned that slope is the same as rate of change. So y equals my slope that I found, which was 5/4 x. And because this is a proportional relationship, I do not have an initial value other than 0, because it does start at my origin. So now I have my equation. What is nice for this is now I can decide whatever minutes I want to try to figure out. I can now use this equation to figure out how many equations she can solve. All right, last one. Go ahead and turn over to problem number 3. All right, so Mrs. Johnson and Mrs. Smith paid babysitters differently. So we're going to look at this table below. And I see that I have hours. Sorry about my S going down to the next line. And I see Smith and I see Johnson. So I know that my hours is going to represent X. And this is a different kind of table than what we've seen before. But rather than doing 2 tables, I tried to make sure that we were just condensing a little bit. So my hours is X, while Smith is 1Y, Johnson is my other Y. So we're going to focus them one at a time. So basically I'm going to cover up Miss Johnson. And I can see here that it's just a normal XY table that we've had in the past. That for 0 hours, Mrs. Smith, myself, pays $0. For 1 hour, pays $9. For 3 hours, $27, and so on. So now if I want to go ahead and focus on Miss Johnson's, I have to cover up mine. So you can see it's the same idea. For 0 hours, though, Miss Johnson pays $4. So for 1 hour, she pays $12. 3 hours, she pays $28. And 5 hours, she pays $44. So when I'm looking at these 2 different relationships, are both of these relationships proportional? Well, in order to answer that question, I have to remind myself, what does it mean to be proportional? Well, we know that proportional has to go through the origin. It has to start out at 0. So one of these relationships starts out at 0. And we can see that's Mrs. Smith. So my relationship is proportional, but Mrs. Johnson's relationship is not, because we see that when X equals 0, my value is 0, but Miss Johnson's value is 4. So no, both of these relationships are not proportional, because Mrs. Johnson starts at $4. Or in other words, when X equals 0, Y equals 4. So now we get to graph them. And this time we actually get to graph 2 lines onto the exact same coordinate plane, so that way we can kind of compare them and see what we notice. So we're going to use my table just like I did in the past. And we're going to see that my X is labeled as hours. And this one only goes up to 5. So I think what I want to do is I want to leave some space in between, just so I can see this graph a little bit better. So of course it's going to start out at 0, but I'm going to skip a line and write 1. skip a line and write 2, skip a line and write 3, and so on and so forth. Make sure your scale stays the same. The biggest mistake that I see is people will start 1 right here, skip a line and go 2. Well, now here you said your scale, that this value was worth 1, and then you changed it to be worth half. So make sure your scale starts from 0. So my y-axis, we can't write Smith and Johnson because these are two different things. So we've got to come up with something that we can label them so that we can understand what we're looking at. So if we look back at our context, it says that Mrs. Johnson and Mrs. Smith pay babysitters differently. So literally, that's what I'm going to label my graph, my y-axis. I'm going to label that as babysitter pay. So when I'm looking at my scale, I see that for me, Mrs. Smith, it goes from 0 all the way up to 45. And Ms. Johnson goes from 4 to 44. Well, I have 20 lines on my graph. So what I think I'm going to do to try to be able to fit in the most points possible, I think I'm going to count all of my lines by 2. So 2, 4, 6, 8, 10, all the way up to the top. Perfect. So now it's time to plot my points. Well, I have two different colored pens. If you don't, you can graph them in pencil and then we can take a highlighter and go over them. But first I'm going to go ahead and I'm going to graph all of my points. So according to Ms. Smith, at 0 hours, I pay $0. At 1 hour, I pay $9. So here's my 8 and my 10, so I know my 9 has to be right in the middle. And then at 3 hours, so I didn't even write down what I did for 2 hours. So at 3 hours, I've got to jump over here. I pay $27. So I go up here, I see 26 and 28, so I know I have to be in between. And then at that 5 hours, it was $45, which is off my graph, so we're not going to worry about that. I'm going to line up my points and go ahead and graph it. So at this point, if you wanted to take your highlighter, one color highlighter, you could highlight this line and then just make sure that you label it that we know which is which. Which is which. So that's my line. So now I have to go and label Mrs. Johnson. So at 0 hours, according to my table, Mrs. Johnson pays $4. Just for showing up, she pays you $4. At 1 hour, she pays $12. At 3 hours, she pays $28. And again, at 5 hours, it's at $44, so it kind of goes off our chart, our coordinate plane. I'm going to go ahead and line these up. And now we can see where I drew Miss Johnson. You can see my two different colors. So again, same thing. If you want to take another color highlighter and just highlight that line, just make sure that you have the two lines labeled so that you know which line is which. So now we have to figure out the slope. Part D is asking us to figure out the slope of each line. Well, like we did before, it was nice within our context because we were able to find that proportional constant. So looking at the graph, it might be a little tricky to try to figure it out. So in fact, I kind of like using the tables a little bit better. So if I want to go and try and figure out what is the slope of the Smith line, I'm going to literally look at my table. And I'm going to grab a couple of values. So I'm going to look between this value and this value and see how did I go from 0 to 9. Well, I added 9. And now, excuse me, now I got to look at my x values, and I want to see how did I go from 0 to 1. Well, I added 1. So if I set that up as my proportional constant, which is going to be my change in y over my change in x, I see that I'm going to have 9 over 1. Now I can leave it like that, that's acceptable, or I also know I can do 9 divided by 1 and have that whole number of 9. Both answers are acceptable. Just remember there can be no decimals. So now I have to basically do that same thing with Miss Johnson. So I'm going to check to see how did she go from 4 to 12. Well, I see she added 8. And of course, I'd already figured out for my x that from 0 to 1, it was 1. So I'm going to set up her slope, which is going to be 8 over 1. Again, I can leave it like this, or I can do it as a whole number of 8. So now it says write each slope as a rate of change to interpret its meaning. What does it mean? Well, if I look and see what my y and my x or my y values represented, that was the amount that I pay a babysitter, or Mrs. Johnson pays a babysitter, and I know that my x represents my hours. So in my case, it means that I pay a babysitter $9 per hour. However, Miss Johnson pays a babysitter $8 per hour. So now we have to explain these different y-intercepts, because if you remember when we graphed them and we looked at our table, for some reason I started at 0 and Miss Johnson started at $4. So the reason being could be anything. You can kind of come up with any different reasons. Mrs. Zurzo, who's sitting here working diligently, why do you think Mrs. Johnson pays $4 at 0 hours? Just to show up, she pays you $4.
Can I order a pizza?
So she's given her some extra money to possibly order some pizza. Maybe she's just thrilled that she's coming to babysit for her. Okay, so Mrs. Johnson pays a babysitter $4 just for showing up. Okay?
Maybe her kids are brats.
Let's hope not. Johnson is legitimately another 8th grade teacher. Just so you know, that's why that comment was made.
Who has older children.
Who has much older children who are not brats, and they actually do the babysitting. All right, so Mrs. Johnson pays the babysitter $4 just for babysitting. And maybe that's $4 to go get some ice cream. I don't know if $4 will buy a pizza, but it'll be a little bit something towards it. All right, so now this is an interesting question. Is one babysitter job better than the other? So if you were sitting here and you were going to babysit for either myself or Mrs. Johnson, which job would be better? In other words, which job would actually get you more money? So I kind of want to go back and I want to look at my graph. So off the bat, I'm sitting here thinking, I'm like, well, Mrs. Smith pays $9 an hour. Of course I'd want to go to Mrs. Smith. But then I remember that Miss Johnson, although she pays $8, she just gives you $4 just for showing up. So I'm looking at my graph and I noticed something. I noticed that right here, right at 4 hours, my two lines intersect. They crisscross each other right there at that 4-hour mark. So if I look at my line, from 0 to 4 hours up to here, I can see that who actually pays better. Well, Miss Johnson. She is up here. She's got that higher amount of money. If you look per hour, she is actually a better deal. You get more money that way. However, it's a little harder to tell here with my line, but after that 4-hour mark, oh, suddenly I pay better. So in order to answer that question, you have to look about how many hours you're going to be babysitting. So it's really going to depend on the number of hours. So if it's between 0 and 4 hours, as it turns out, Miss Johnson is the better deal. You'll get more money for babysitting. However, if it's 4 or more hours, it's actually better to babysit for Miss Smith. So last but not least, what we have to do for this problem is we have to write that equation. So remember, again, the equation is y equals that rate of change times x plus or minus my initial value. And now we've determined that my rate of change is the same as my slope, and we've talked about that my initial value is the same as that y-intercept. So when we go to do Miss Smith's line, it's going to be y equals, my slope was 9x, and because I was a proportional relationship and I started out at 0, I don't have to write any initial value. So Miss Johnson was y equals 8x because her slope was 8. However, she does have an initial value as she starts at $4, so I have to do plus 4. So at this point, please go ahead and take your guided notes up to the substitute teacher. The substitute will look through and see if you have everything filled out, and then we'll give you your homework.